But we're just going to talk about two things today. Law of detachment and law of syllogism. Those are the only two things we're going to talk about today. That's the whole lesson, is just understanding these two big concepts. So let's just talk about deductive reasoning real quick. We'll go through the definition and kind of what it means. But like I said, today we just need to take away the law of detachment and law of syllogism. If we get those two things down, we're good with today's lesson. All right, deductive reasoning is just the process of reasoning logically and drawing a conclusion from the given facts and statements. Drawing a conclusion from the given facts. All right, as you write that, we already talked about deductive reasoning. That's where we came up with our conclusion. We used inductive to come up with that pattern. Remember, we'd write that pattern of the numbers, and then we use deductive reasoning to actually come up with our conclusion. So all deductive is, hey, I got to come up with a conclusion about the facts that happened. All right, and that's what today is about drawing conclusions upon given if-then statements. But we're actually able to draw more conclusions, just it's true or false. And the very first one we're going to talk about is the law of detachment. The law of detachment is basically if I give you an if-then statement. So remember 2 days ago, I guess I said, remember how I said, if it rains after school, I don't have practice? What if we then learn it rains after school? What can we conclude? There's no practice. That's the law of detachment. If your hypothesis comes true, that means your conclusion will happen. If it rains after school, I don't have practice. Hey, it's raining out. I don't have practice. Matthew, can you take that out? All right, so given a conditional statement, if the hypothesis is true, so if the hypothesis comes true, is true, then the conclusion is true. Now, this is totally based upon the if-then statement being true to begin with. So if the hypothesis is true, then the conclusion is true. Here is the symbolic map. It might not make a lot of sense to you guys, so it might just have to do with you just remembering if the hypothesis comes true, then the conclusion comes true. But here's the map of the symbolic map. So first of all, we have a conditional statement. Remember, your conditional statement just says if P happens, then Q. That's what we did 2 days ago. We said if P, then Q. The law of detachment adds one more fact to it. P happens. So P actually happens. So P is true. So we're given an if-then statement, and all of a sudden P happens. It rains after school. Now we're going to add a new mathematical term to you guys. You see those three dots that make a triangle? In math, that stands for therefore. Q happens. So I started with, if it rains after school, then I don't have practice. That was my conditional. Then I get some more facts. That's my P. Hey, it rains out. Therefore, I don't have practice. So our law of detachment gives us that extra bit of information that Q then happens. Okay? So what we're trying to do not overthink this, because some people look at the whole thing and they try to confuse themselves thinking really hard. You just have to figure out what your hypothesis is and then make sure your conclusion comes true. Hey, we just started. We're talking about the law of detachment. I think you'll figure out as we're going through it. Okay, so if your hypothesis comes true, then your conclusion. So all you're trying to do is figure out what your hypothesis is and ask, does that come true? Anything else, you can't make a conclusion. So let's go back to my statement. If it rains after school, I don't have practice. What if we learn I don't have practice? Does that automatically mean it has to be raining out? What if it's Saturday and I don't have practice? What if we had something after school and we didn't have practice besides rain? So the only conclusion we can make is if the hypothesis comes true. Because notice how that conclusion came true on that one? It was the baseball pack. That means nothing to me. That means no conclusion. Even if you can reason out it's probably raining out because you probably said this on a Monday or something like that, if you have to reason your way through it, it's not the law of detachment. The law of detachment strictly says the hypothesis has to come true. So when we're looking at the law of detachment, we're just looking at the hypothesis. So let's do a couple examples. So use the law of detachment to give a valid conclusion. If that is not possible, write no valid conclusion. So we start with, if Mark saves $30, then he can buy a new video game. Mark saves $30. Now here's the thing. What was my hypothesis? What is my hypothesis for this one? We just took a quiz on it. What's the hypothesis? Yeah, Chris. Mark saves $30. Do we put if in there? No. And we're going to lose half a point if we put if on our quiz. It has to just say Mark saves $30. We're using the law of detachment. I don't care what the conclusion is yet, but we should also note that our conclusion is he can buy new video games. All right, so it says if Mark saves $30. That's my hypothesis. Does the hypothesis come true? Does Mark save $30? Yes. This matches my hypothesis. Those two things match. Your hypothesis came true. So my hypothesis came true, so my conclusion is Mark buys a new video game. It says if he can save $30, then he buys a new video game. He did save the $30, so Mark will buy a new video game. Mark can buy a new video game. I could spell buy. Buy a new video game. Let's just call it VG. All right, the next one says if a quadrilateral is a rhombus, then it is also a parallel. You are 18 years old. Perfect. Which means the thing after the then is our conclusion. Now, you are 18 years old. That is our hypothesis. Olivia is not 18 years old. Did my hypothesis come true? No. Your hypothesis did not come true. This is where people overthink it. So I'm like, okay, Olivia is not 18 years old, so she can't register for vote. You can't make that conclusion based upon the law of detachment. Law of detachment doesn't talk anything about if your hypothesis fails. It's only if it comes true. Is it pretty easy to think that she won't be able to register then? It's very easy to think that. That's where people get mistaken. We are using the law of detachment. The law of detachment says, did the hypothesis come true? It did not. The hypothesis did not come true. We have to dumb down our brains a little bit on these. We have to say, did this exact thing happen? If this exact thing didn't happen, then there's no conclusion. Your hypothesis did not come true. Hypothesis is not true. And because of that, there is no conclusion. It is not, I can figure out what's going to happen. It is, here's the facts. Did the hypothesis come true? No. No conclusion. Let's take a second and do the next two. Is there two left? Okay, make sure you have the next two done. You might want to check with your group because I'm going to call on a random person to give me their answer. If no one wants to help me out. On number 4, can you draw a conclusion? Caroline.
Measure J and K both add up to 90 degrees.
Measure J and K both add up to 90 degrees. Or, love it. I love that we knew the definition of complementary, but we should use what the conclusion says, and that is complementary. Awesome that we knew the 90 degrees. I would be totally cool with that. But, so we have, if the sum of the measures of the two angles is 90 degrees, does that come true? Does the sum of those two angles equal 90 degrees? So it came true. So our conclusion must be the measure of angle, or not the measure of angle J. We would just say angle J and K are complementary. So it has to say what the conclusion means. So it must say angle J and angle K are complementary. Like I said, some of these, we just overthink them a little bit. Because we thought, okay, I know the definition of complementary, I might as well just say they equal 90 degrees. But we have to use what the conclusion says. It says complementary. So we got to be careful about that. Number 5. Who got a conclusion? Put your thumbs up if you got a conclusion. Put your thumbs down if you didn't get a conclusion. Raise your hand if you didn't do any of that stuff I just said. Let's all volunteer. All right. Put your thumbs up if you had a conclusion. Put your thumbs down if you didn't have a conclusion. So everyone should have something. Okay, we're kind of split between having an answer and not having an answer. Let's take a peek at this. You plan to attend prom. That's our hypothesis, right? Does this say Sarah plans to attend prom? That's my only question. Does it say that she plans to attend prom? No. So it does not match the hypothesis. It matched the conclusion, right? Because the conclusion was you must purchase a ticket. It says Sarah purchases a prom ticket. It makes sense. It makes sense if you buy a ticket, you plan to attend prom, right? But that's not what the law of detachment says. Law of detachment says if your hypothesis comes true, then your conclusion comes true. Did the hypothesis come true? No. So this would be no conclusion. Your hypothesis did not come true. You got it. Right? Doesn't it feel like you have to dumb down your brain just a little bit? Because you can't think through the problem. Law of detachment says you basically know nothing about the problem. You don't know what the solution is. All it says is if this happens, then this happens. If that happens, then this happens. If anything else happens, no conclusion. I don't know. We could suss out something. Sarah purchased a prom ticket for someone else. She has no intention of going to prom. She purchased it for someone else. Do we know for a fact what's going to happen? No. We can think about it. We can hypothesize. But the law of detachment says your hypothesis has to come true. Otherwise, it's no conclusion. Clearish on that? Make sure you know that. Like I said, if you need to put your notes, dumb down your brain. You got to dumb down your brain on those. All right. Let's talk about our last thing. That is our law of syllogism. Law of syllogism allows you to draw a conclusion from two conditional statements, in which the conclusion of the first statement is the hypothesis of the second statement. So if the conclusion of your first statement is the hypothesis of your second statement, you can It's basically you're just joining two statements together. You're pasting them together because they're joined at the same statement. So the symbolic map of that is we start with our conditional statement, if P then Q. Then we're given another statement that starts with Q. If Q then, because we have a separate statement, we can't use P again, so we will use R. So we have a statement, if then Q, and then the other one starts with our conclusion and goes to another conclusion. Then we know, well, P then R. We can put those sentences together and get rid of the middleman. I'm going to play you a clip of a video. It's a little old. It's from DirecTV. Let's see if I can bring it up. This is the definition of law of syllogism. It's kind of bastardized. Like they kind of do their own spin on it. But let's take a peek at it. Oh, I need sound. Sound is important to this one. Sound is on. Is it on here? No. All right, let's see how loud this is going to be.
When your cable company keeps you on hold, you get angry. When you get angry, you go blow off steam. When you go blow off steam, accidents happen. When accidents happen, you get an eye patch. When you get an eye patch, people think you're tough. When people think you're tough, people want to see how tough. And when people want to see how tough, you wake up in a roadside ditch. Don't wake up in a roadside ditch. Get rid of cable and upgrade to DirecTV. Call 1-800-DirecTV.
So that was the law of everything that happened was based upon the thing that happened before it, right? And they basically linked that to if you keep cable, you're going to end up in a ditch. That's their whole thing. We can skip all the other stuff. You end up in a ditch if you keep cable. Is that true? Probably not. I don't know. I don't have cable, so I can't say yes or no. So that's your law of syllogism. You must have a link between your two statements that links them together. So let's see some examples of that. So number 6 says, if it is Saturday, then Jake has a baseball tournament. Now, for the law of syllogism, your big thing is your conclusion. You have to make sure your conclusion matches the hypothesis of the next statement. So we end with, Jake has a baseball tournament. The law of syllogism only works is if the next statement says pretty much the way this one ended. The next one says, if Jake has a baseball tournament. Does that start the way the other one ended? Yeah. So because these two things match our conclusion with the hypothesis, we can paste these two statements together. We can paste these two statements together. So because these two things join up, we can make a shorter statement. We can cut out the middleman. So how we're going to rewrite this is we're going to rewrite this as if it is Saturday, just like remember how I said if you don't have cable you end up in a ditch? I just want the beginning and the ending if we're using law of syllogism. So I don't want to know about Jake having a baseball tournament. I want to go straight to then he will need to pack a lunch. We want to be as concise as possible, and I want to know what's important. If it's Saturday, I have to pack my lunch. I don't need to know why I need to pack my lunch because that was already connected in the middle. I just want to know what starts and what ends this statement. Caroline? Yeah. Does that make sense? Okay. Let's check out the next one. So the next one says we're using law of syllogism. We're checking to see if we can use the law of syllogism. I'm given two if-then statements. Remember, to join them up, the end of one statement must match the beginning of the other statement. So our first statement is if a number is divisible by 12. So our hypothesis is a number is divisible. But for law of syllogism, I care about the conclusion. So let's circle that. it is divisible by 6. Our job with law of syllogism is, does the next statement start off with a number being divisible by 6? Yes, it does. It says if a number is divisible by 6. So the beginning part, it's important, it's our hypothesis, right? But to use the law of syllogism, we first have to see if these two things match up. For law of syllogism, your conclusion has to match your hypothesis of the other statement, so that these two things can paste up. I kind of think of it as they get pasted together. But Quentin, the first part's important because this is where we rewrite this with the first part and the very end part. Because we're gluing them together, we're going to make one quicker sentence. So this said, if a number is divisible by 12, then it's divisible by 6. If a number is divisible by 6, then it is divisible by 3. So we can cut out this middleman and just write it as if a number is divisible by 12, then it is divisible by 3. Does that make sense? So the syllogism, we're looking for syllogism to see if we can paste it together. And if you can paste it together, then we start with the first and we end with the second statement. Just like with the cable TV, if you have cable TV, you end up in a ditch. I don't care how you got there, that's what happens if you keep cable TV. Okay? Is that a little clearer? Okay, so once again, we have to see if we can use the law of syllogism. I think I want to skip one of these. Let's skip to number 9 together. Number 9 says, if it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. To use the law of syllogism, your conclusion has to match your hypothesis. So my conclusion here is you will go boating. The hypothesis for the next one is it is sunny this weekend. Do those match up? No. So you can't paste those two statements together. Like I said, don't be too smart for this. Don't just be like, oh, if it's sunny out, then you wear shorts. Because that makes sense. But we can't use the law of syllogism to get there. Those do not match up. And so you cannot make a conclusion. Because those don't match up, we can't make a conclusion. So this didn't match, so we have no conclusion. Ooh, rain. Opposite angles are congruent. What you're trying to do is you're trying to find a hypothesis that starts with opposite angles are congruent. This one has quadrilateral is a square, quadrilateral is a rhombus, quadrilateral is a parallelogram, quadrilateral is 4 right angles, a quadrilateral is a rectangle. Oh, the opposite sides of a quadrilateral are, whoa, I missed the wrong one. I circled the wrong one. What one did I want to circle for the example? Let's just do the parallel one. That's not the one I wanted, but we'll do this one. See how it says opposite sides are parallel? So let's retrace. We're looking for a hypothesis that says opposite sides are parallel. And that's F. Do you see how F says opposite sides of quadrilateral are parallel? So those two match up. This one can be pasted onto this one. So one of our statements can be, if a quadrilateral is a rhombus, and we pasted that together with F, we're just going to end in, then it is a parallelogram. If a quadrilateral is a rhombus, we start there, we paste it, and we end with, then it is a parallelogram. And I got that from here. What I want us to do in the next 17 minutes is I would like the ones that you skipped, or I skipped, I want those done. I want you to get them checked off by me, that you got them correct. And then I would like you to start this one. If we get this done in class 2, I can check it off as well. Otherwise, it's part of your homework. Are we clear we don't have to do all those rest of them? We just do this one, and then the next page is homework, right? It says homework on the top after that page. Can we all be clear what our homework is? That I'm not making you do 4 pages of homework. We're just starting at 10 and then going to the homework page, and that's our homework. Questions? So we're doing those 3 for sure, and we're going to get checked off before we leave. If we don't get them checked off, then we can lose points for the day. You should have time to do it, right? You already have it done? All right.
Yeah, perfect. Good job.
So you do have